Hey everybody, today I'm going to be showing you guys how to make your very own standalone Arduino circuit. Now, the best benefit to having your standalone Arduino circuit is that if you were to fry the board, you're able to just replace it, because for the most part you just need to replace the chip. Instead of having to spend a lot of money to get a replacement, change the chip, you're good to go. Another big benefit is the price. So it costs about $3 to $4 to make your own circuit, as opposed to buying it, the official version, quote unquote, from the Arduino company, which can run you $30 and up when you include shipping and handling. So the materials that you need for your standalone Arduino is first your Arduino reference sheet. Now, to be honest, the chip that is used to make the standalone Arduino is actually called the ATMEGA 328. So Arduino is the company. ATMEGA is the chip the company uses for their boards. So it'll actually be quite incorrect to call it a standalone Arduino, more so standalone ATMEGA circuit. So from now on, we'll just be calling it the standalone ATMEGA. So you need your reference sheet, which is here. I'll actually have a link to the picture itself so you can look it up. It'll be in the description of this video, so you can pull that up, and that'll be our ATMEGA pinout reference sheet. You're going to need a breadboard. You're going to need an FTDI chip. You're going to need male wires. And going from left to right, you're going to need a 10 kilo ohm resistor, two 22 picofarad ceramic capacitors, one 100 ohm resistor, a single color LED, the color doesn't matter. You need a 16 megahertz crystal oscillator, a 100 microfarad electrolytic capacitor, and you need the ATMEGA 328P, which you can find on all types of sites. You can find on eBay, Amazon, a lot of different sites. Now, what you want to make sure you look at is pulling out your ATMEGA pinout reference sheet, you'll see a small divot. And if you look at it closely, you can see a small little divot here on the chip. That lets you know the proper orientation, so that when you're hooking everything up on the breadboard, you don't make a mistake and put the wrong component in the right component in the wrong place. So before you put on a breadboard, what you want to do is bend the legs. So this one is already has already been bent so that it can be on the breadboard. But what you want to do is just make sure you hold it carefully and just apply enough pressure for the legs to bend. You don't want to put extreme pressure, but just enough for it to do what it needs to do. And I have a piece of black E-tape here on the breadboard because I'm going to have this divot face the tape so that I know the proper orientation, so I don't accidentally flip it around and whatnot. And when you actually press this down, you want to make sure that the legs aren't getting bent or damaged in any way, and if they are, adjust it as necessary. But if the leg does break, you will have to get another board, another ATMEGA chip, which costs about $2, so you can just buy in bulk and be good to go from there. Okay. Other components you'll also need is a micro USB cable. You'll need an actual Elegoo microcontroller. This is an Arduino clone. So this is actually similar to what you get from Arduino, but this is a lot cheaper in price. But you have to have a Arduino or Arduino clone board. Like I said, it's better to get the generic version because it's a lot less expensive, but that's up to you. And of course, the cord that comes with it. And I also bring tweezers to help me count the holes. So using your ATMEGA reference, you want to get your 100 microfarad electrolytic capacitor, and you want to put the negative pin, which will be, if you look closely, you can see this stripe here, this gray stripe. That lets you know that this leg is negative. Now, what you might notice is that the legs are the same length. That's because I cut it to make it easier to slip this component into the breadboard. So put your negative into the reset. So negative goes into reset. Then what you want to do is get your 10 kilo ohm resistor, and you want to put one into the positive, one leg into the positive, the other into the reset. Then you want to go ahead and get your tweezers, and you want to count up. So where it says OSC1 and OSC2, which will be on the left side. It'll actually be here. You want to connect your 16 megahertz crystal oscillator. So you need to count up 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. You want to insert your crystal oscillator, one leg into each position. And you want to get your 22 picofarad ceramic capacitor and put one leg into the same position the same position the crystal oscillator was put in, and the other leg into your negative. And you want to do that for both. Okay. Once you have that inserted, we're going to get your 100 ohm resistor, and we could just put it in a random place on the breadboard. Just make sure it's away from your ATMEGA. And we're going to have the single color LED hooked up with one leg going into the leg, into the same position of the resistor, and another leg just kind of hanging out. Okay, so that's all you need for this first part. Now the next step is to hook it up so that you can upload the bootloader, because typically when you get these ATMEGA chips, they don't have the bootloader on it, which is why you need this generic board here. So people normally say to use specific colors for your wires, like red being for VCC, black being for ground, yellow or white being for the signal. But as long as you pay attention to what's getting plugged into where, you shouldn't have any problems. Just make sure you pay some special attention. So I'm just going to grab some random different colors so I don't get confused, because you don't want 2 or 3 of the same color, because that heightens the likelihood of failure. And what you want to do is connect a male pin. You want to make sure you connect that to one to VCC, which will be your 5 volts, and then connect it to the breadboard VCC. And then you want to connect your ground to the ground in the breadboard. Next step is you want to get your wires, and you want to connect your pin 10 of the LED to the reset pin of your ATMEGA, pin 11 to pin 11 in your ATMEGA. It's 9, 10, 11. ATMEGA pin 12 to your LED pin 12. Your LED pin 13 to your ATMEGA pin 13. Okay. What you also need to do is get 2 male wires and connect one. We'll connect this one to your VCC, and then connect that to the VCC on your ATMEGA chip. So if you look close at your reference, you'll see one that has VCC. So you have your oscillator here, you have your ground, then here's your VCC here. And then, of course, you just want to connect your ground to the ground. Now, if you look on the right side, you also see a VCC and a ground. So you want to do the same thing on one side you did to the other. So we'll just connect it here. So now here's your VCC, and here's your ground. And you want to connect it there as well. So we have our pin 13, then right after pin 13 is your VCC. So here's VCC on the right side. Skip one hole because that's your analog reference. We want to skip that one, and then connect your ground. All right. So that is all you need to get your wiring done to hook up the ISP, which is your bootloader. So the next thing you want to do is connect this to your computer. Okay. Now we have it connected. Now let's switch over to the computer and we'll go from there. Alrighty guys, so here we are in our Arduino IDE. First thing you want to do is go to File, Examples, and then go to 11 where it says Arduino ISP. Once you click it, this pops up. You no longer need this. Click the X. And then you want to verify that you're using the right configuration. So we have Arduino Genuino Uno. The COM port is good. and you have the programmer as the Avrisp MK2, okay? And you want to go ahead and upload the sketch. So now that you have everything uploaded, the next thing you want to do is go into board, and you want to change it now. So change it to Arduino, whatever this word is, or whatever this other word is that I'm not going to try and pronounce. The processor is going to stay the same. The port should stay the same. And your programmer, you're going to change it from Avrisp MK2, and you're going to select Arduino as ISP. Okay. Once you do that, you want to open up Tools again, and you want to click Run the Bootloader. So go ahead and select that. Once it's selected and it's fully uploaded, we're going to go ahead and switch back to the workbench. Now that you have everything uploaded, if it uploaded successfully, you now have the bootloader connected and uploaded to your ATMEGA rig. So what we're going to do now is disconnect all the pins that are from the Uno to the breadboard. So we'll just take all this, hold it, and then pull all that out. Don't need it anymore, and you don't need this. All right, so, and we can unplug this as well. All right, so now what you want to do is get 2 wires, and what we're going to do for this example is connect 1 pin from here. It'll be, if you look at your reference, it'll be pin 9 of the ATMEGA, and we're going to connect that to the 100 ohm resistor, and then we're going to get the other leg, that'll be our ground, and connect that to our breadboard ground. Okay, once you have that connected, the next step is hooking up your FTDI. So if you look really closely at it, you'll see going from the top to the bottom, ground, CTS, VCC, TXD, RXD, and DTR. So we're going to grab this, and we're going to hook it up. So we're going to get our ground and connect that to breadboard ground. We'll connect it here. Okay. We're going to skip CTS. We do not use CTS. Now we have VCC. We're going to connect that to breadboard VCC. Next, we have TXD of the FTDI, and we're going to connect the TXD of the FTDI to the RXD of the ATMEGA. The FTDI RXD, we're going to connect to the TXD of the ATMEGA, which is right next to it. Okay, and then your DTR, that is your reset. So you want to connect that, not to the reset pin, but to the positive side of your electrolytic capacitor, your 100 microfarad capacitor. Okay, now what we need to do is go back to the computer. All right, so if you look in the description of this video, you'll actually see this piece of code. This is what you want to insert into your Arduino IDE. One thing you want to make sure of before you connect it is that the jumper, it has a little jumper on it, make sure it's connected to your 5 volts. All right, so once you have the jumper on 5 volts, you want to go ahead and put the micro USB cable into your FTDI. All right, cool, now it's connected. So what you want to do now is to go to your tools, and you want the board now needs to be Arduino this word with this word that I'm not going to butcher. Your processor, it stays the same. Let's click out of that, we don't need that. Your COM port should be the same. Now your programmer you need to change. So your programmer needs to be Avrisp MK2. Okay, once you have that, you don't need to click verify. You can just upload it because I already know that this works. So long as you follow the instructions and making sure that all of this was good, you can upload it successfully. And now you have everything working. So congratulations, you have uploaded the Blink sketch to your ATMEGA rig, and from there you can do whatever you want it to do. It's the same thing as having your Arduino Uno or having an Elegoo Uno or whatever generic brand you try out. So here is a circuit that I put together. So this looks a lot better than what you see here, since this is the breadboard type. This is the actual version that I made a long time ago. So this has a 5-volt linear voltage regulator with 2 capacitors. I actually rigged it up so that, let's see, once I have this disconnected, if I wanted to reprogram this, all I would have to do is line it up correctly so that this is ground here, connect it, and you can just sit it on there. So once you sat it on, you connect to the micro USB, which is connect to your computer, and then you just upload whatever you need to. And it would already be powered from here. And once you remove this, you would have 2 headers, 2 different headers that you could put your positive and negative into. Now, this is grossly inefficient, and this is like one of my first designs. This is old. It's not trash because I like to keep memories of that time when I was just getting into programming, but it is a version I have made. So what I really like is that this is a lot slimmer. If you take away the power section, it's really, it's pretty slim. I took all these wires out. In my next iteration of this, I would take all the wires out and just connect everything as you see here with the FTDI cables. You would just get it, and then you just put the wires in where they need to be, which is pretty simple, especially if you're using your ATMEGA pinout diagram here. So that is the end of the video. One thing you want to make sure is that if you are going to have it similar to this, have a layout like this, make sure that you buy this 28 position dip, which is your socket. And that is so if you happen to fry your board for any reason, you could actually just pop it out of this adapter and then you can put a new one in. So we don't need this anymore since I already showed you how to do it. So we can pull this out and I'll just show you. Just take this out. Make sure you align the divots together because there's a divot here on the adapter. So the divot's right here. Get the divot of the ATMEGA. Make sure you're careful with it, and then you just plop it in there. It'll be a lot better if you hold it from the sides like this, and then just press. All right. Like I said, I don't like having this adapter when I'm connecting it to the breadboard because you can't get a really good connection. But when you're doing it here and you're programming it, it's a lot better. It's a lot easier to have it nestled in there since everything is soldered on instead of just sitting inside of the holes. So that is the video, guys. Thank you for watching. Please like, share, subscribe. Leave a comment in the comment section below. Share it with your friends. And please hit the bell icon so you can be notified of future updates and video posts that I make. See you guys later. Have a blessed day and goodbye.